So in this lesson, we're going to look at different ways we can do word problems with sequences. The first question says, a store manager plans to offer discounts on some sweaters each week in an attempt to sell them before the winter season ends according to this sequence. $48, $36, $27, $20.25. Write an explicit formula and a recursive formula for this sequence. So the first task we have to figure out is if it's arithmetic or geometric. Arithmetic is easiest to check. So if I go down the line, if I subtract these two, 48 minus 36, that's going down by 12. The next one is going down by 9, so it does not look like it's arithmetic. If I try dividing and I do a sub 2, the second thing, right, divided by a sub 1, the first thing, so we'll write that up here, 36 divided by 48, that would give me 0.75. If I move down the line and I did a sub 3 divided by a sub 2, I would also get the 0.75. And that would continue on. It would work the same for 20.25 divided by 27. So that tells me that we have a geometric sequence. We know that our multiplier, or b value, is 0.75. For our explicit formula, that's very similar to our a times b to the x formula. So we're going to write a sub n equals our start value. Here is 48, so a sub 1 times our b value is 0.75. And remember, this is the first thing, not the zero thing, so that's why we use the n minus 1 to basically shift it over 1 to the right. So that's explicit. So an explicit formula just basically means a function formula, similar to what we've been writing all year. The second one, recursion, we want to say what we start with first, always. So we're starting with 48. To get to the next number, I take the last number in the sequence, and I multiply by 0.75. So this is our recursive definition. And that just basically says where we start and how we get from term to term. Let's look at the next one. It says, after one customer buys 4 new tires, a garage recycling bin has 20 tires in it. After another customer buys 4 new tires, the bin has 24 tires in it. Write an explicit formula to represent the number of tires in the bin after n customers have bought 4 tires. So after one customer, so my first number, we have 20. Then we have 24, and if people keep buying 4 new tires and putting them in the bin, that pattern will continue. So we can pretty easily see that this is arithmetic. So we're going to use the arithmetic formula. We just want an explicit formula on this one, so we're just doing, I'm going to write it out this time, a sub n equals d times n minus 1 plus a sub 1. So that's our explicit formula, very similar to mx plus b, but we're shifted over 1. My common difference is 4. I have n minus 1, and I'm starting with 20. So that's our formula, and you want to be careful on these that you actually write the formula in addition to then doing the problem after that. Looking at my next one, it says, or next part of the problem, it says how many tires would be in the bin after 9 customers buy 4 new tires. So we're talking about finding a sub 9 here. So that means I'm plugging in 9 for my n. So this is 4 times 9 minus 1 plus 20. And that would be 52. Now, if I just continued listing numbers out here, I would get to 52 on the 9th number. So that's another way you could do something like that. So let's look at the next one. This one is a little tricky. It says, Lainey has decided to add strength training to her exercise program. Her trainer suggests that she add weightlifting for 5 minutes during her routine the first week. So we're starting with a 5. And each week after, she is going to increase the weightlifting time by 2 minutes. So that means her second value will be 7. Her third value will be 9, or I could write it as a list like that. Now, when I initially look at it, I can tell I'm going up by 2. That's my D value. So initially it looks like 3 or 4 is going to be the answer. I'm going to write out the formula the way we see it. 3 is super tempting because I see the 5 there too. But if I write out my sequence formula, my D is 2 times n minus 1 plus my a sub 1 is 5. Now, I see the same numbers in 3, but I have to account for the n minus 1. So we don't usually do this when we're just writing a formula, but we can simplify this. So this is going to simplify to 2n plus 3. So that is the correct formula. So you want to be really careful. You want to really work through it and get down and eliminate down to your final multiple choice. So the next one, we have a graph of a sequence. It says the graph to the right models a sequence. Does this function show a linear or exponential relationship? So it's not connected like a continuous function, but we can see we could draw a straight line through there. So we'll say linear. So because we said linear, should we find a common difference or a common ratio? We should find a common difference, right, because we're adding. So it looks like every time these go over 1, it's going up 4. And I can actually list out this sequence, which we always really want to do if we're stuck or if something's tricky. Writing that list of numbers can help. So I have negative 12, negative 8, negative 4, 0, and 4 is what I can see. So my common difference, I'm adding 4. We're going to write an explicit and recursive formula for the sequence. So I suggest doing this on your own, okay, and then coming back and checking, but I'm going to write them down now. An explicit formula, D times n minus 1 plus a sub 1. A sub 1 is negative 12, so I'm going to write negative 12 there. Recursion, I start with a negative 12. And to get to the next number, I take the last number, and I am adding 4. The next question is super similar. It says the graph to the right shows the number of teams left in the women's basketball tournament at the beginning of each round. So before the first round starts, we have 64 teams left. Before the second round starts, half have been eliminated, and we have 32. So this is what's going on in the graph. We see exponential, right? We see that curve. And therefore, we are going to find a common ratio. Now, I kind of just said it's a half, right? And that's how we know the tournament works. But if I'm going to list out those values, 64, 32, 16, 8, and so on, I can see if I take the second thing divided by the first thing, 32 divided by 64, I do get 1/2 or 0.5, and that would continue if I worked on the line. So my common ratio is 1/2. So now we're going to write an explicit formula for the sequence. So a sub n equals a sub 1. So my start value is 64 times my base is 1/2, or my ratio, to the n minus 1. Remember, because we're starting at that first term. Recursive formula, what do we start with? We start with 64. And to get to the next term, we take the last term, and we are multiplying by 1/2. And I just want to say again, you can always write the 1/2 in the front, and you might see it that way more often. But just to kind of keep it similar to my adding patterns, I just kind of always put it at the end to make it consistent. Exercise 6, now we have a multiple choice question, and we have to decide which one of these fits the scenario. So this is recursion because I see my a sub 1 and then where I'm going. A sub 1 equals 3,000. It says, and then a sub n equals 0.80 times a to the n minus 1. So we often are putting that 0.80 at the end. Little information we can tell from this, if I have 0.80 left, going back to our exponential functions, that means it's decreasing by 20%. We can find that from our 1 minus 0.80, which is 0.20. So if I look at each of these situations, first row of the stadium has 3,000 seats, that's good, but then each row after has 80 more seats, that would be an adding pattern, arithmetic pattern. The next one is similar but says 80 fewer seats. So both of those are arithmetic. A bank account starts with a deposit of 3,000 and each year it grows by 80%, then I would expect to see 1.80, right, as the multiplier in my recursive definition. The initial value of a specialty toy is 3,000, and its value each of the following years is 20% less. That one looks good, and it matches my function, or my definition. Okay, so this one is similar, but now we're going to say what it says. We do have information. It says this is a recursive formula. It can be used to model the amount of money in Rebecca's bank account. It says explain what information is given by the formula. Assume n is measured in years. So if this is her account in the first year, the account has $6,500. And then from this base, if I subtract the 1, the amount in the account increases 4.2% per year. So that's just a little combination with those exponential formulas.